Come in.
AJ, sorry.
Hey, Sam.
Are we heading down to composite integrations tomorrow?
Yeah, we are. I'm just going through it at the moment.
Okay. Do you want to run through?
Yeah, so composites are key to what we're doing. They're really, really important. They allow us to make a really streamlined fuselage that also has all the inbuilt crashworthiness that we need and everything else. The problem is traditionally they're hopelessly expensive.
Right.
You end up buying the materials in a really expensive format, so they come with the carbon fibres pre-impregnated with resins. All of that is pre-certified.
Right.
You have to keep them in a fridge. When you bring them out of the fridge, they've only got a finite amount of time before you can use them. They're sticky and awkward to work with, and there's
Right.
lots of wastage. So what we've done is we've pulled in some of the composite technologies from other industries like wind energy, boat building, vehicle building and manufacture.
Right, okay.
To take a much more pragmatic and a much more production orientated approach towards composite. We're actually buying aerospace grade carbon fibre as dry fabric. You know, that's the cheapest way that you can buy it. We can keep it on a shelf for years if we needed to. You wouldn't, but you could. And then what we do is we add the resin to this separately. And we do that using an infusion process. And to make sure that our sort of rollout of that is seamless, we're working with Composites Integration, who we're going to go and see tomorrow, who are process experts. So they specialise in providing all of the computer-controlled equipment that you need to do the infusion process.
Right.
So to hold the right vacuum. So we've got to find a way of doing all of that, and we're going out to test some resin-compatible binders tomorrow to make sure that we can actually stick the dry fibre to the sides of the tool so that we can put the fibre in place before we put the vacuum bag in there and before we infuse. So the way we do that is we've got a tool that comes apart into 5 pieces. It's on a rollover rig so that you roll it over a side at a time to lay in the fabric. So that's all the fibres and the cores going into the belly of the aircraft. Then you put the nose piece on. Then you roll it over and put the sides piece on. If I just pull my fibre back. And the other clever thing that we do there is when the bits go into the mould, they're folded over like this. And then in these corner areas, you overlap one side, then the other one, then the other one, then the other one. So you've got complete fibre continuity across the joints in the mould. So as far as the structural integrity of the components considered, it's been monolithically laid up all the way round. And that eventually goes together until you've got all your sides on. You can then vacuum bag it, inject the resin, and then disassemble the mould, and your carbon fuselage is ready to come out. So to be able to do that, the only thing that we've got to prove we can do is stick that stuff to the roof. And predominantly that's what tomorrow is about.
Cool. Awesome.
All right.
I'll
Let's
see you
go.
tomorrow.
Smash it.
Thank you.
See you in the morning.
See you in a bit. Morning, Craig. How are you?
All right, you.
Yeah, good. Morning, Jason.
Morning, Sam. Richard and Tim and all those guys. Thank you. Yeah, no worries, thank you.
Good morning.
Good morning.
Hi, Jason. How are you? You alright? Do you want to come through?
Yeah, that'd
I'm
be lovely.
Steve, by the way.
Give me 2 seconds, I'll be with you.
One quick question, Tim, over there. You said the head of the resin might be significant. How's that going to play when we've got a fuselage that's 1.6 metres tall? And you can do that in a distributed fashion around the tool, so you can compensate for the stuff going at the top and the stuff going at the bottom.
So we've got what we've got. So we've got a nylon bag. Here we use 2 types of tacky tape. So this is our low temperature, low cost tacky tape. The next thing down here is that we have to have some way of distributing the resin. It's us to distribute the resin across the surface, because with the kind of viscosities of resin that we're using for this job, if we didn't have this, the resin will probably it'll probably quite quickly get to about here, and then it will grind to a halt.
So what's your gut feel about that, Tim?
Well, this
do you
one's
think?
better.
But can you get it to the right standard? Is it repeatable enough? Can you infuse
it's
it?
repeatable.
Yeah.
Yeah, and it's infusible, but you need to be informed that, you know, don't design a 10mm stack of this, or actually even a 3mm stack, because
Because it'll still look like that when it comes out.
And the other thing is that we test it. You know, you don't, we don't go into this blind. You know, we test it all.
So what is it? Just 2 plies or 2 top, 2 bottom?
So there's 4 plies here.
Yeah.
And the foam's in the middle.
Yeah.
So
Okay.
2 plies either side.
Yeah.
Completely arbitrary, but that's what it is. And it's literally.
And what's the weight of those plies that you've got in there?
400 grams.
So it's the same
as your testing.
So it's what we've got. Yeah.
So this is kind of your entry level. And that is just has some vacuum channel.
The prototypes, because we can just change it until our heart's content. Yeah. But in reality, you just want to be able to flop the vacuum bag into the tool, and you're done. Squirt the resin in. And so that's a much more streamlined process. It's dead fiddly. It's really difficult to get a vacuum, and it's dead fiddly. You've got to deal with all these consumables and everything else, and it just takes a long time to do that. Yeah. But this is perfect for prototyping because we can keep changing stuff using the same tool. Yeah. But when you go to that stage, you design the tool and the bags together so that you minimise the amount of labour and the amount of time it takes to make the individual parts, but you can't do that until you've tied all of the process parameters down. Right. How long does it stay tacky for, Tim, and does it require heat to be tacky?
Until it drops down to 50 or 60.
Ah, okay, so it relies on, and can you remelt it and reheat it? The big challenge with infusion, particularly when you're trying to make a one-piece fuselage, is being able to secure the carbon fibre to the roof before it's got any resin in it. And what this resin-compatible adhesive system that we've got here allows us to do is to systematically apply the right amount of glue, if you like, in between the plies so that we can stick the plies together and form them over the foam reinforcement, and then, crucially, to stick that stuff to the roof of the mould so it enable us to put all of the fibres inside that multi-piece mould to make the fuselage and make that in a single piece. So what we've demonstrated today is that all of the key enabling techniques and technologies exist to allow us to make the one-piece fuselage, so it's really important, really exciting. So we came down to make sure that we could take these low-cost forms of composite materials and secure them in the mould on the side vertically using this resin-compatible binder, and that's been a complete success. So there is now nothing preventing us from using these lower-cost production methods for the composites with high-quality materials to produce the composite fuselage for HX50. So we're very grateful for Composites integration, and yeah, it's all looking good.
Sweet, thank you. I'll see you soon.
Okay, cheers, Sam.
Bye.